Right, with the M2 International Paper, June 2014, question 3. Uniform rod AB is freely hinged at A to a vertical wall. The rod is supporting equilibrium at an angle of 60 degrees to the wall by a light rigid strut CD. The strut is hinged at D and to the wall at the point C. So it's fixed there. It could just turn around if it wasn't attached to the other end as well, which is vertically below as shown. The rod and strut line the same vertical plane, which is perpendicular to the wall, and the length of the rod is 4A, and AC equals AD, which is 2.5A. We're going to show the magnitude of the thrust in the strut is 4 root 3 over 5W, and find the magnitude of the force acting on the rod at A. Right, so here we go. That's 120, put some angles on it. That's 120 degrees there. Now, because AC is equal to AD, both of these are 30 degrees, isosceles triangle. Now, the force is acting on the rod. There's going to be a horizontal force and a vertical force at the wall, but I'm not going to worry about those because I'm going to do moments about A. It's got the weight acting down in the middle, so this length would be 2A. And there's a thrust in the strut pushing back up on the rod, which is trying to fall down this way. But I'm going to draw it like this because I think it's easy to see a sort of tension, sort of a pull in that direction, the same size, is going to have the same effect as a push in that direction. So it amounts to the same thing. So you imagine a string pulling it this way rather than the strut pushing it that way. It amounts to the same thing. Now, this thrust, this tension, is going to have a component along the rod and a component perpendicular to the rod. That angle's 30 degrees because it's the same as that one, which makes this one 60. Now, I'm going to get rid of this one because that component goes through A. The line of action goes through A, so it's not going to have a moment. Just this one, which is T cos 60. Same with the W. I'm going to need this angle here. It's got a component perpendicular to the wall and parallel to the wall. That's 60, so that is as well, which makes that angle 30 degrees there. And again, I'm going to lose this one because the line of action of that component goes through A. So the forces I'm looking at then are the T cos 60 and the W cos 30. I just need the distances for the moments. That weight acting in the middle, so that distance is 2A after 4A. This one was 2.5A. And then looking at the moments then, the moment of this one is going to be W cos 30 multiplied by 2A. This one's going to be T cos 60 multiplied by 2.5A. And they're going to be the same. It's in equilibrium. It wants an exact answer in terms of W. So to simplify, I'm going to get rid of the A's. I'm going to double both sides, make that 5 and that 4. Cos 30 is root 3 over 2. And cos 60 is a half. So that's 5 over 2 times T. And this is 4 root 3 over 2 times W. 4 root 3 over 2. And then multiply by 2 over 5. Multiply by 2, divide by 5. I get the required answer. Right, now what is the magnitude of the force at A? So it's got a horizontal component and a vertical one. I'm going to need to break this up into horizontal and vertical components as well. So because this angle's 30 degrees here, it's a right angle. That one's the same angle. This one was 30 and that one was as well, so it leaves this angle is 30 up here. Now, of that T has got a component going to the right, so this one's going to have to be going to the left because they're the only horizontal forces. Not sure about the vertical one yet. If we look at the vertical forces though, acting upwards, I've got the Y and the T cos 30. That's going to balance out with the W acting down. And then to find out what the Y is then, I'm going to do W minus T cos 30, this times root 3 over 2. This simplifies down to 12 over 10 times W, or 6 over 5 times W, giving you minus a fifth W. So actually the y does act downwards because you've got a negative answer. Then look at it horizontally. Horizontal forces, just the x and the t cos 60. I'm going to turn it through an angle of 60 degrees to make it horizontal. So times by cos 60. So it's this times by a half, which is 2 root 3 over 5 times w. And I want the magnitude of this reaction. So we'll do Pythagoras with these two components. So the r squared is equal to x squared plus y squared. This squared, that's 12 over 25 times w squared. This one is just 1 over 25 times w squared, giving me 13 over 25 times w squared. So the r is root 13 over 5 times w.